Well, hi, good morning. Thanks so much for joining me in my shop here. It's November 20th. So I'm stuck for time today because in a short while I'm taking delivery of 3 big old radios like this. 3 more of these guys. So today I think it might be a good time, considering the radio appears to be operating fairly well at this point, to take a look at the magic eye in this radio. So lots of radios of this vintage have magic eyes. And magic eyes are they're used as a signal strength meter. The thing about them is they can monitor or be sensitive to the AVC voltage without putting any load on the AVC system. So that's what makes them so great. A meter needs current. It's got to get the current from somewhere. That might require an additional stage put into the radio to drive the meter. But these eyes, they don't need any drive to operate. Yes, they need heater current, but that's no big deal. So that's why they're in these radios. People like them. This one in this radio is installed in a bit of an unusual place. You know, it's looking right through the panel. Now, the first time I saw this, I thought, well, this is kind of goofy. Like, yeah, you have trouble seeing it through the words and stuff that's written on the glass in front. But then I thought, well, actually, it's not that goofy, because when you're tuning the radio, where is your eye? Your eye is usually on the pointer. Well, the signal strength is right here. It's just a short distance. So maybe it does make some ergonomic sense to have it in the middle there. Quite a few of them are like that. And normally these eyes have two basic problems. One is they're worn out. They just won't glow. They're done. The tube itself is worn out. And the other one is there's a resistor in most of these installed right in the eye tube socket. That's a 1,000,000 ohm resistor, and it's almost always bad. And when it goes bad, the tube stops operating properly. I'm not sure if that makes it dull or not. Now, this tube is dull, so I'm going to put it in the tube tester right off the bat and find out what we're up against here, because maybe it's a bit of a lost cause at this point. Let's see if I can get it out of here. There we go, and I don't want to move these wires too much because of their potential for breaking. We have to get the tube out of the socket. Changing the resistor in the socket is not an easy deal. You have to get this plate out of here, this black plate. And most of the time when I'm doing it, I break them. Okay, they're not a critical component. So here we are. What do we got here? 6U5. So there's a few different there's 6E5, 6U5, a couple different versions of this tube. Some are shorter than others. Just going to leave the bracket on for now. Now I'm going to get them in the tube tester, and we'll see how bright it is and whether or not it operates properly. So as you might imagine, testing these tubes is a bit of a different matter from a regular tube. This has no center post. This is a pretty old one. Now let's just double check everything here. 6U5, 6.3 heater voltage. Signal level doesn't matter. Bias should be switched to the H setting, but we're going to vary the bias to vary the brightness, or vary the opening, not the brightness. 75531, 75531, 6000, 6000. E, this doesn't matter. What goes on the meter doesn't really matter. Okay, we're ready to go. No, we're not. now. There we go. Now I have another camera here ready. Let's see what's happening. I would say it's not glowing. Let me darken things down a little bit. I saw the glow in the radio itself. Darken down some more. There. You can see the glow. Okay, with my eyes, this is so faint as to not even be glowing. Unfortunately, it seemed a little brighter in the radio. Okay, I'll give it a. It still seems to be warming up a bit. So what can happen here is the cathode can wear out, but also the green phosphorus that's glowing here can wear out. I would think. Just off the top of my head. Okay, I'm going to vary the bias, and we'll see if it opens and closes here. I don't see anything happening at all. Well, if we can't get convinced that it's working, there's not going to be any reason to try to fix it. So these tubes are available, you can buy them. They almost all have mileage on them, I would think. Wow, it's a little disappointing. I was pretty sure I could see it better. Let me just go a little darker yet. Okay, try the bias control again. Ask ourselves, is the tube tester doing its job? Now, I've tested other eye tubes in here, and the answer is yes. I think I'm going to put one in. Maybe we'll put one in for experimental purpose. I'll see if I've got one here, a good one. Okay, so I think my my collection here of magic eyes, I think they're all weak and dead. Let's see if they have an actual 6U5. It says 6U5, 6U5, 6G5. Big X on it. This one's got an X on it, another X on it. 6U5. Here's a shorty. 6AD6. And here's an oldie. 6E5. 6 looks like N. 6N5. I'm not sure what the middle letter is. It's a great number of pins. Yeah, this one has an octal. Loctal rather. Loctal, octal, octal. Well, let's give these guys a try and see what happens. Even though I've got an X marked on it. 6U5, we're right in. Bring down the house lights. You can see the heater's glowing. And that's about all you get out of this one. Just the red glow of the heater visible. Okay, well, it's a good thing it has an X on it. Now here's another one. We're going to try. Just checking the label on it. 6U5. Hint of green there. Okay, so it's a dud. It's a good reason there's an X on it. And this last guy, I'll have to check my on the proper settings for this last one. How about a little more light in here? N5. Not that we can. Well, I don't think we can use that. But let's see what the tube tester says about it. 6N. 6N5. It says it can't test it. Wait, that's a K. KLN. 6N5. There it is. Bias must vary shadow. So it's definitely for a. It's exactly the same settings all around. It's exactly the same settings. Okay. This one does not have an X on it. Let's give it a go. Not very hopeful. Let me just check these numbers and be sure I didn't make a mistake. 6N5, 75531, 75531. Very same. Settings, 6000. Oh well, it's way. There's something happening on this one. Okay, vary the bias. Let's see what happens. The little pie-shaped opening that's on the left side is changing size a little bit. Now in a totally dark room we're in right now, I can see that with my eyes. But to be honest with you, what is 1,000 times brighter is that green light right there. The pilot light from my tube tester. Well, that's not the best story. I don't have an eye unless I fish it out of, hey, I'm getting some radios shortly. Maybe one of them will have an eye. And I think, you know what, I think I've got one or two more radios with eyes in them that haven't been in my shop yet. Yeah, I have quite a few of these old shortwave radios to work on this winter. I'm going to go see if I can find an eye. Okay, I stole this one from another radio. I have actually three or four of these. I have a number of these here in the shop in instruments. 1, 2, 3 I can count quickly. But I'm not going to take the ones out of my instruments here. So, okay, does this one even work? Let's see what happens here. You really shouldn't need to be in a dark room to see one of these operate. Well, there's the red glow. Where's the green glow? Oh, here it comes. Wow, this one looks pretty good actually. Now, looking at it with my eyes, it's, you know, if this was a fully lit room, let me make it that way. Fully lit room, you never know it's on. So it's another case of a dark room thing. Let's change the bias here and see what happens. Well, it moves a bit, but not much. So this might be good enough for us to carry on with the radio and do testing and the like. And like I say, a couple more radios, 3 more radios are showing up. I'll bet you there's a magic eye in them. I bet you it's worn out too. But we got one here anyway that is good enough to see and should do the trick. At least I can make the radio ready for a new magic eye tube. These are expensive. You can roll out $100 to get one of these. Well, I've just taken delivery of 3 big old radios. These are being gifted to me from someone who just doesn't want them anymore. And oh my God, 2 of them are late 20s, early 30s radios, big honking things on spindly legs. Great big cabinets. Oh my gosh. And the last one is a radio similar to this, 1940s type radio. So Wow, okay, it should be interesting. My own experience is radios out of the 20s and early 30s, pretty tough, pretty tough. Problems with getting tubes and things like that. They're simple radios. If you have the tubes and stuff, not hard, not too hard to get them going, but yikes. Okay, let's get back to this one. I'm going to plug this tube in to the radio, and we're going to see what we see with it. And these tubes, 2 pins are fatter than the rest. These 2 here are a little bit fatter than the rest. These are the heater pins, and they're fatter to guide them into the socket correctly, but also they're carrying the filament current. So I guess making them a little bit fatter makes some sense. Put them in. Okay, and then we just need to prop it up here. Oh, I need to do a few things to this radio to get it ready to run again. So I'm going to do that. Just about ready to go here, and when I'm not in my shop here, I'm in my rec room watching TV, and I'm watching BBC Earth. They're playing a program about the American Apollo space landings. Very interesting because they're using actors to play all the roles, but all the sound is the actual recordings of communications back and forth from the moon and Earth, and it's very, very interesting. Do you remember where you were when the Americans set foot on the moon? I remember exactly where I was sitting. It was late in the evening, and we watched I guess Neil Armstrong. We watched one of the astronauts come down the ladder, jump on the moon, and all that kind of stuff. I was just beside myself. I was a little kid, but I was beside myself. I found this stuff so exciting. And we watched for another couple minutes, and my parents said, "Okay, you've seen it, time to go to bed." And I said, "This is something, people on the moon, this is something, you're going to see it again and again, Jim. Go to bed." And I had to go to bed. I've never forgotten that, and never forgave my parents for doing that. Oh my gosh. Okay, little side story there. Now what we're going to do is we're going to turn on this radio. I've got my signal generator running. We're going to feed a strong signal on a shortwave band. Let's try that one and see if the eye will respond or not. So let's, maybe a little brighter in the radio than it was otherwise. So this frequency would be on what band? Let's just see what band. I want to do this around. Oh yeah, like this. Yeah. So we want to do this, say, around 11.8. Dial this up to 11.8 or so. Okay, and then we want the radio to be on the 25 meter band. 25 meter band there, and tuned roughly in the middle. 1.8. About here. Okay, we're ready to go here. Let's switch on. Okay, for sure I have not reconnected the 3 little wires here. I believe these wires only need to be connected when you utilize the push button features here. The other cable coming down from these buttons, you can see it here, this has to be plugged in because the audio from the radio is sent up to enable this switch to switch it over to phono. And that's why, very oddly, the phono input is up here. I guess they didn't want to pay the money to run the wires back down, or maybe running them back down. I don't know. They didn't do it anyway, so it's kind of odd. You really have to get down and look up into the back of the cabinet to see this, to even know it exists. Okay. Volume down. That's one thing for sure. Okay, here we go. Dim bulbs. Getting the right response there. Let's just bring down the house lights here a little bit. Okay, close this over. Okay, first of all, is there any glow on there? Oops, my door's open. Let's give it full power because that's going to make a difference. Oh, look at that. So that's easily visible. I mean, you can tell in the camera, that's plenty bright. Now, the next question is, will it operate? You know, I might be able to make a more interesting picture of this. Just take another camera, stick it here, and we look through. There we are. Okay, let me turn it down the volume a little bit. We don't need to hear all that. Now I am going to tune the signal. Oh, whoa, oh, no, that was too bad. Okay, we have a camera that went flying here. Still flying around. I don't know what you're seeing, but it's been a wild ride. Wild ride on the camera there. Okay, I'm going to tune the signal generator until it picks up, until it comes through in the radio. Okay, and what's the eye doing? Zero action in the eye. That's surprising to me. I thought it was going to work. Okay, this is probably due to the defective, to a defective resistor installed right in the socket here. So we're gonna have to go after it. It's the only way to get this working. So the larger objective at this point is to prove the radio is eye ready. I can call it that, eye ready. The owner can decide if he wants to buy an eye. They're very expensive, and I have very few myself. Here's one, but I don't want to give it up. Okay, resistor in the socket. Yeah. Okay, let's take a look at the resistor that's in here. Now, I faced this quite a few times. Each time I got to pull that plastic cap out from here in order to get at the resistor. And what this cap is doing is it's holding the pin clips, if you like, in place. So you pull this cap out, the pin clips can slide forward on their wires. And you pull the cap out, my experience is it gets busted. This one, I've never found a neat way of doing it. This one looks a little different. This one looks a little different. Let's take a closer look at it. And I'm going to adjust the focus here so we can get up really close and take a look at what's going on inside there. No, it's the same as the others. So you can see the cracked edges of the plastic. There are little, I don't know what to call them, snap overs. You would snap this over. See, there's a guide there, so it only goes in one way. And it looks like this has not snapped over the snap overs. Instead, it's been distorted. This looks like you might be able to pull this one out. Now there is a bit of an opportunity to come in from behind. Yeah. And push something up past these wires and contact the black piece here and push it out. But I haven't found that to be too successful. So what I usually do is I stick a hook through one of these holes and start yanking. And that's when the thing usually breaks, and that's the end of this black piece. Then you have to put it back together without this black piece in there. It's not the end of the world. It means when you pull the tube out, the pin grips are coming with it, and you have to kind of slide the pin grips off, and it's a hassle. But I mean, how often do you change these tubes? Not too often anymore. So maybe I should try pushing it from behind, but it's probably wedged in there pretty tight. Maybe I can push something up from behind, and in doing that, figure out how loose that cap is. Maybe the cap is loose in this one. So what would I push up there? I'm going to push something up there. I wouldn't want to push something up there with a sharp point on it, like this. Just want to see if the cap is loose. I don't know if I can even get this in past the wires. Yeah, feels like it. I'm going to spear myself. Oops. So I'm looking to see if the the black cap is moving at all. Alright. Let's change the lighting here a little bit. My creaky lights. Okay. I need to strike it with something, with some, not a lot. Strike it with something that does not have a lot of mass. I don't think anything's happening at all. Not doing the trick. Let's try a more powerful approach here. Still on a soft, springy surface here. I don't think it's moved at all. I'm not exactly sure what I'm hammering either. Okay, so we'll try pulling on it. I use this guy to do it. Coming. Broke it. Broke a piece there. That's what's going to happen to this. It's going to break. Now it's weak in here. Go on the other side. Maybe it's loose over here. Broke it. I hate this. I hate doing this kind of thing, but I guess, you know, this was meant to go in and never come out. Meanwhile, the wires to this is pretty stiff too. It's shaking them around and jerking them around. Not the best thing. I think this is going to be in little pieces when I'm done. There's another piece gone. So now maybe you know a trick to getting this out. you're cringing as I do this, and I'm cringing too. Ow! I've drawn blood. It's getting me back. Doesn't like what I'm doing. Now I'm breaking it on purpose at this point. Because I'm mad at it now. Come on. There it goes. Swing. So the resistor is almost certainly in that cover there. So now we'll try to push the wires through and get the resistor to pop out. That's not working. Could have tested the resistor beforehand. The other thing is you want to keep all these in the right order. Don't want them to change order. Come on. So you might say, well, why in the heck did they do that? Why did they put this in the cap? Because the Magic Eye was almost like a separate unit, if you like, that you could just with wires, stick into a radio. You could there it comes. They all come loose. You could stick it in a box and put the box on top of the radio, run the wires in the radio, and have yourself a Magic Eye. Okay, now we don't want any of these to change position. Yeah. Don't anybody move. So the resistor's probably in there. I should probably check it at this point. Still have some blood left. Let's just check it and see what we can see. I have to find my hey, where's my voltmeter? Where's the voltmeter? Here it is. So it should be a 1 million ohm resistor there. Now if I measure this and I get a million, I'm going to kind of be upset. Let's hope that doesn't happen at this point. So I'd say it's from here to here. It would appear to be open circuit. Check my meter. Yeah, the meter's working. Says it's open. I mean, you gotta, sticking a resistor inside here is sticking it into a small oven. Okay, I could just cut it out at this point. I leave enough that I can tell where it came from. Leave enough wire behind. Okay, I wasn't quite expecting that. They cut the capacitor lead without cutting the wire. So the terminal that fell out is simply hooked up to the resistor. Okay, that's good. Just leave that like that. Leave that like that. And look upon the resistor. I guess, they got to use a very, very tiny resistor to fit in there. And consequently, it's a low wattage resistor. It's a combination of a low wattage resistor and a high temperature location. And these are almost always shot. So there we see brown, black, green. That's 1 million. There's not much left of it to test here. Double check. If I get a million now, I'm going to cry again. So it would certainly appear to be open. With this open, the eye cannot function. It could still glow, but it's not going to change. It's as with the signal. If you want to learn more about how these Magic Eyes work, rather than me try to explain it, because I'd have to go read up on it again to explain it, go on the internet. There's lots of fantastic websites about Magic Eyes. I guess people have found them very interesting, and there's great explanations of how they work. It's not quite what you might imagine. There's a bit of a trick to them in how they operate in terms of controlling the voltage that's applied to the control grid and whatnot. So do I have a little teeny tiny one? Now there's no reason why I have to put the replacement here. In fact, I could put the replacement down under the radio even if I wanted to, rather than up in here. A lot of these, what they've done is they position the resistor so it comes out the back here a little bit. This one, the resistor is so small they got it right across here, but a lot of them The resistor goes down, and then the one lead comes back up and makes its connection. So that's kind of what I would tend to want to do. And stick a much higher wattage resistor in it that way. A higher wattage resistor is going to run just a touch cooler too on its own. Not that these are conducting heavy current. I don't think they are. I think they're just in an oven. Okay, time to oh my gosh, time to have lunch. Yeah, I've been distracted so much today. Lunch. Okay, I've got a new resistor installed in there. It's hanging out the back here. Problem with this is there's high voltage right here, and I didn't get it covered, but won't worry about that too much. The real problem is I can probably get the tube in, but when I pull the tube out, it's going to pull out all these sockets are going to come out with the tube, and probably and almost certainly pull off the resistor wires. So even putting the tube in for a test is probably going to wreck the situation in there. But what else can I do? So I'm going to put it in a bit, and we'll see what happens. Okay, that's a bit. Ready for another test. Let's see how this goes. Again, what we're trying to prove is the radio is ready for one of these tubes. Boy, oh boy, oh boy, oh boy. Okay, look at our close-up camera ready. Let's fire up the radio. I have to turn on my signal generator here. Okay, douse some light. There, it's coming on. Okay, let's just put it on full power here. Okay. Appears to be completely closed. Take a look with this other camera. Well, it's closed. That means it's receiving a strong signal. I don't think that's too likely. Okay, signal generator. Make it come in and out here. What has happened? It's behaving like it has a signal. If I wiggle the tube in the socket here, if I scream yow, you'll know why. I can't imagine that. Yeah, you know what? I can't imagine there's a loose contact in there. How did we end up with this? How did we end up with this? Let me tune in again. Well, that's a little bit on the disappointing side here. Yeah, that's on the disappointing side, all right. What has not worked out here? Push it deeper in the socket. I think it's making contact now. Even just pulling this out now to take another look is going to probably destroy the way I've got the resistor installed there. It's not the end of the world, it just has to be reinstalled. Did not work. And this is responding to the AVC voltage. I think we need to take a look at the AVC voltage and see what's going on with that. Okay, got the set operating again. It's a negative AVC voltage there. We'll just tune the signal generator. So the top voltage we get there, that's on the 15 volt scale. So that's about 10 volts. And the lowest is about 5. The eye is still doing exactly the same thing, is it? Sure looks like it. Yeah. Huh. Well, okay. Stop and think a bit about this. I don't want to do anything too precipitous because the thing is so fragile. And so am I. Yeah, I'm going to think about this for a while before I try another move on it. Okay. I mean, I'll get back in here again today. In fact, I have other things I need to work on. So, yeah, I don't know. I have to finish this off tomorrow. We will see.